Okay, so good day. Today we are going to discuss the analysis of structures, so in particular trusses and frames. Now we have several methods uh, that that will be used in analyzing trusses and frames. Okay, so we have the method of joints, we have the method of sections, and then we have the method of members. Now the first two methods that I have mentioned that is best in analyzing trusses, while the methods of members that is best in analyzing frames. Okay, now basically what we are doing here is we only determine the internal forces acting on each member of your truss, or the reactions at every joint, so that you will be able to design properly the cross section of your member. Okay, so that is already beyond the application of analysis of structure or simple structures. Okay, so let us start with the method of joints. Now in method of joints, you have to assume that all members of a truss are two force members carrying axial loads. So which means that the free body diagram of any joint is a concurrent force system in equilibrium. Okay, so you have to draw before you go on with your solution. You have to draw first the free body diagram, which means that you have to expose the internal forces acting on the members of your truss. Okay, so you will be able to form or create a concurrent force system, and you have to remember, or you have to recall, that when we say concurrent force system, you can only use two conditions of equilibrium. You have the summation of forces along x, and then you have the summation of forces along y is equals to 0. Okay, now remember that this method of joints, this is only applicable for uh, trusses. Okay, so we have several steps in using a method of joints. So first is you choose a pin or a joint in which no more than two members act. So asa madapitan ni nga mga pin or joint ang imong pangitaon. So this is joint A or pin A, joint B, joint C, and so on. And take note that uh, in the step, ingon siya nga no more than two members act. Anong no more than two members man? Or shall I say, ang imong unknown dapat ana nga joint, kung ana ka dapita nga joint, is that you should have uh, a maximum of unknown nga duha ka buok. So you have two maximum unknowns kana nga joint. It's because what you're dealing will be a concurrent force system, and recall again nga sa concurrent force system you can only use the summation of forces along x equals to 0 and the summation of forces along y is equals to 0. Okay, so and then the second step will be draw the free body diagram of the selected pin or joint and assume initial direction of forces. So you have to draw the free body diagram of whichever joint that you prefer to start with your calculation. And then you have to assume the initial direction of the forces. It's either in tension or it's either in compression. When we say your member is in tension, meaning it's tends to elongate, okay, or uh, tends to elongate your member, which means that the force is acting away from the joint. Okay, so acting away from the joint ang imuhang force. Kung tension, kung compression, tends to compress your member. So that is towards the joint. So if you will draw the free body diagram here at joint B, you have forces for member AB, you have force for member BC, and then you have force for member BE. Okay, so you can assume the direction of BC as tension, meaning away from this joint. You can assume that the direction of AB is also in tension, that is directed away from joint B. And you can also assume that the uh, force for member BE is in tension, that is away from joint B. But in joint C, your force BC is also in tension. Dili siya padong sa joint C. Away gyapon siya sa joint C. Okay. The next step is that mark the original structure with the appropriate arrows showing the direction of forces. Okay. And then from the original truss, select another joint with the two unknown forces. Repeat steps 1 to 4 until all required forces are determined. Okay, now, so let us apply that step here in the problem or in the figure T01. Okay, find the forces or the force acting in all members of the truss shown. So you can see that we have this simple truss in the uh, right support. In the right support, the support, we have a rocker or a ruler support. Then sa left support, we have a pin or hinge support. So for pin or hinge support, you have a vertical reaction. It's either downward or upward. And then you have a horizontal uh, reaction. Okay, it's either to the left or to the right. Okay, and then for a roller support or rocker, you only have a one reaction that is perpendicular to the surface of contact. It's either upward or downward, to the left, to the right, whatever the orientation of the surface of contact. Now for this case, your surface of contact is horizontal, meaning your reaction at that joint or that point or at that support is it's either upward or downward. Okay, now to start, you have to determine the reactions at each support. Okay, now based on the figure, you have only one horizontal force, which is 80 kilonewtons, that is going to the right. So which means that the horizontal reaction at uh, joint A or pin A or hinge A should be opposite of the 80 kilonewton. So it should be to the left. While uh, A vertical and B vertical, you can solve that using the summation of moments or the summation of forces vertical at any point. Okay, so by doing that, you should be able to solve for A vertical as 3.33 kilonewton, which is downward, this one. This is A vertical, and then your D vertical or the reaction at D will be upward, which is equals to 3.33 kilonewtons. So you have to apply the fundamental knowledge that you have learned from the equilibrium of parallel force system for this one. Okay, and then with the reactions known, we are ready to solve for the forces in each member. So you can start in member or joint A, so showing the result reaction, vertical reaction at joint A, which is 3.33 kilonewton downward, and then your A horizontal is 80 kilonewton, that is to the left. Okay, and ingon sa Jagalina, you have to assume the initial direction of your forces. So forces along AB is assumed to be tension, so that is away from joint A. Then forces for member AA is also force for member AA is also assumed to be in tension, that is away from joint A. Okay, so this 3, 4, 5 triangle is only based from this triangle B EAB. Okay, 0.75, and then this is 1. So this is basically 3 or 4. So the slope of this line or AB is 5. Okay, so you have 3, 4, and 5. So with these assumptions, you can apply the summation of forces vertical and summation of forces horizontal is equals to 0. So this is the vertical reaction of your force AB. So applying the summation of forces vertical is equals to 0, assuming forces up. You see the symbol. Is force up positive. So you have FAB 3 over 5 times 3 over 5. That is uh, the vertical component of your force AB. So FAB sine of theta. Your sine theta is 3 over 5. 3 over 5. So that is equals to 3.33. So equals to 3.33. So you have your FAB as 5.55 kilonewton, which is in tension. Okay, so it is correct that you have assumed, we have assumed the correct direction of your FAB. Okay, now since we have the value of FAB, we can solve for the value of FAE. Okay, applying the summation of forces along horizontal is equals to 0, assuming all forces going to the right will be positive. So you have FAB cosine of theta. So your FAB is 5.55, your cosine of theta is 4 over 5, okay, minus 80. So since 80 is going to the left, so that's minus, plus your FAE is going to the right, so that is plus FAA equals to 0. So your FAE is equals to 75.56 kilonewton, which is in tension. Now, if ever you have uh, arrived in a negative answer or with a negative answer, you have to you, your answer is not wrong, but rather your assumption of the original or your assumption of the initial direction of your force is wrong, but the answer should be correct. Okay, sakto ra ang imuhang answer pero ang assumption sa direction is the same, so you can only you can change the direction or the orientation of your force. Okay, so if ever that you have come up with an FAB of negative 5.55, meaning the assumption that FAB is in tension is wrong. So this must be in compression if FAB is 5.55. Okay, because you have assumed initially that FAB is in tension. Okay, so we'll try to solve for another force. So okay, so we have here at joint B. So it is known that the value of FAB is 5.56 kilonewton. So that is tension away from joint B. So your unknown will be FBC and FBA. So here we have assumed that the value or the direction of FBC is going to the right while FBA is in compression. Okay, so FBC is tension, FBE is in compression. So applying the summation of forces along the horizontal is equals to 0. Okay, forces horizontal is equals to 0. So you only have the horizontal component of FAB. Then you have FBC. So you have FBC minus FBE 5.55 times cosine of theta. Your cosine of theta is 4 over 5 is equals to 0. So FBC is 4.44, which is in tension. If ever you have arrived with a negative answer, meaning FBC should be in compression. Since you have assumed that this is in tension, so imo mag-assume nga tension, dapat kung negative ni, compression na siya. Okay. And then applying summation of forces along the vertical is equals to 0. So you have two forces. You have the vertical component of FAB and the FBE. So you have FBE minus 5.55 sine of theta 3 over 5. So your FBE is 3.35, which is in compression. Okay, so again, we have arrived with a positive answer, meaning our assumption is correct. Okay, so this would be FBE. Okay, you try to solve for the remaining unknown members.